Alright, hello. So, we're taking a little break from calculus and we're going to move on to some organic chemistry. So, we're just going to do molecular representation today and go over the different ways that you can view a molecule and kind of get into the rules of bond line structure. So, we're going to start off with our molecular formula, C4H10O. That's just our molecular formula, but you don't really know any characteristics or shape of it yet. So if you kind of start, it's kind of different ones that we could look at, like the Lewis structure. You'd have 4 carbons in a row. Our ends would have 3 H's, because our carbons need 4 bonds. Got our OH there, H, H. And we know this from general chemistry. Just get into our review and then we'll move on a little bit. It's our Lewis structure. Something like that, structure. And then we can know this is 2-butanol. And we can get into how to name them in a later video, but just know that this shape would be 2-butanol. So then we could get a partially condensed structure. We're just looking at these 2 carbons in the middle. We know that we'd have CH3 in the end. OH is connected to this guy. H there. We know this is CH2. And we have another CH3 at the end. This is partially condensed. So this kind of still shows the structure, and then if we want it completely condensed, we would have our, kind of looks the same, we have HC3, oh sorry, we know this is a CH3, CH2, we got a CHOH for that third term, and then CH3. So as you know, the Lewis structure looks the best. I'd say this one looks the best. It's the best representation for our 2D model. But sometimes there could be a lot. It could be cumbersome to draw or look at. Sometimes we could work with 30 carbons. How are we going to show that? It might be really tough with all this C's and H's everywhere. So a solution, the easiest thing and what you're going to be using in organic chemistry would be the bond line structure. With the bond line structure, there's a set of rules that everyone follows, and it kind of makes it easy to visualize. So I'm just going to draw how it would look here. Got our OH, and this is 2-butanol as well. So basically we should know that the molecular formula isn't enough, or C4, I think H10O, is that what we're working on? C4H10O, that our molecular formula doesn't give the whole picture. Because instead, if we drew this out again, C, 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 we could have an OH at the end, H is here, one, two, three, four. You got your 4 C's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got your 10 H's and your O. And this is not the same as what we first saw. So That's something we need to know. This would be, if you wanted to know, leave 1, 2, 3, 4. 1, 2, 3. This would be our 1-butanol. So this naming system that we'll get into later kind of shows you how we still have a C4H10O, and it's different than that one up there previously, our 2-butanol. So how do we read these? That's probably very important to know. How do we read these? So for example, we had our 1-butanol, and then we'll just we can do a 2-butanol too. 1, 2, 3. 1, 2, 3. Why am I messing up here? 1, 2, 3, 4. Sorry. Just starting this chemistry thing again. 1, 2, 3, 4 C's and 2-butanol. So just kind of get you used to it. We count the carbons. We would count them 1, 2, 3, 4. We're not getting into naming yet, but that's how you get your 1. It's connected there. And then you have 1, 2, 3, 4. 2's there. So as we know, we saw these previous structures. Let's even draw our Lewis structure with that. So put it in here again. I guess we'll put it OH, H and H. So at each point, I'll go in blue now. At each point here, we know that's a carbon. That would be these guys. We know this is a linear structure, but for bond line, we want to go in these zigzags. So as we can tell too, we have 3 hydrogen on the end, because carbon needs 4 bonds, so it's an implied 3 H's. We know this 3 carbon has 2 bonds here, 1, 2. So we know that there would be 2 H's. Oh, sorry, I didn't draw it. There it is. So, and as you kind of keep going, that's how you know there's 2 H's here, 2 H's on this first carbon. Be the same thing with 2-butanol. I guess we can go over it just for completeness here. Get our carbon, 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 carbon. Get our OH, H. And this is, you can start first time doing organic chemistry, first couple of weeks, you can start by doing this just to kind of really get that grasp down. So again, going green for our hydrogen. This one would have 3 hydrogen. This one would have 1 additional bond because it has 3. 1, 2. There we go. Let's go. Got our H's. Got our 2 H's here. And then 3 on the end because it needs 3 other bonds. So that's great. Instead of this Lewis structure, which is a kind of simpler one, working with bond line kind of speeds it up. So now we just need to go over the rules. So the rules of bond line structures. So, rule number 1, as you might be able to figure out, the hydrogen atoms are not drawn. Makes it, simpler, very decreases the complexity or viewing, what you got to look at. So in our sp2 and sp3 hybridized atoms in a straight line, like our examples, in a straight line, in a straight chain, go straight chain, or zigzag. And rule number 3, the zigzag order doesn't matter. So if we're working with we could have it zigzag this way, or it could go up to down. It's the same. Rule number 4, so besides our hydrogen, besides our carbon and hydrogen, our atoms and their H's must be drawn. Must be drawn. So, going back to this, our alcohol group has an H, an OH, so that must be drawn. It's an alcohol group. You want to show those. So rule number 5 is no more than 4 bonds. 4 bonds for a carbon. There'll be no more than 4, no more than 5 for nitrogen. No more than 6 for oxygen. So for example, something that we'll look at later, like an ester group, C double bond, you get your OR constituent and then your R atom. So here we have 4 bonds to our ester, to our carbon here and our ester, or in an amide, get your C double bond O, 1, 2, 1, 2, R constituent, this one's perfect, it's your nitrogen here, your 2 R's, so you get, so here we have 1, 2, 3, 4, 5 to the nitrogen, which gives you a no charge. In your carbon you have 1, 2, 3, 4. And in your oxygen you have 1, 2, 3, 4, 5, 6. If we had more or less bonds, if we have more or less bonds, then we will have a formal charge on an atom. We will go over this in the next video. Thank you for watching.